Volcanoes, fault earthquakes, rising magma. What's happening in the Mediterranean? It's something everyone's talking about. In these early months of the year, seismic and volcanic activity across the Mediterranean has sparked significant concern among experts and local populations. From Santorini to the Aeolian Islands, spanning Mount Etna and the Campi Flegrei, it seems the Earth refuses to stop trembling, fueling questions and theories about possible links between these events. The idea of an invisible thread connecting these volcanic areas is undeniably compelling. But what does science have to say? Are we really witnessing a broader phenomena, or are these just geological coincidences? While the debate heats up, let's try to untangle what's happening in the so-called Mediterranean fire belt. Since late January 2025, Santorini and the nearby Cycladic Islands have been experiencing the effects of a seismic swarm that's truly tested the nerves of the local population. Only in recent days has the activity shown signs of subsiding. The most significant tremor so far, a magnitude 5.3 quake that struck on the evening of Sunday, February 9th, between Santorini and Amargos, was accompanied by several additional tremors exceeding magnitude 4. This seismic activity caused landslides in various parts of the island, forcing local authorities to secure high-risk areas, temporarily shut down schools and tourist activities, and relocate a large portion of the residents. The affected area, the Santorini-Amargos Fault Zone, is one of the most seismically active regions in the Hellenic volcanic arc, notorious for its capacity to generate high-magnitude earthquakes. Let's not forget the most devastating earthquake ever recorded in the area, which struck on July 9, 1956, with a magnitude of 7.1. It was followed by a powerful aftershock of magnitude 6.9, resulting in casualties, widespread damage, and a violent tsunami. All of this has unfolded in the Aegean Sea, but during the same period, a remarkably similar situation has been playing out about 900 kilometers, or roughly 560 miles away in southern Italy. On February 5th, a strong seismic swarm affected the Campi Flegrei area, a vast volcanic region located in the Gulf of Pozzuoli, northwest of the city of Naples. From above, the area reveals a very distinctive morphology. There's no single volcanic edifice dominating the landscape, unlike Mount Vesuvius, Mount Etna, or other iconic volcanoes. Instead, it is characterized by the presence of an enormous caldera spanning 15 kilometers, or about 9 miles in diameter, dotted with dozens of relatively low-lying volcanic cones. Most of these volcanoes are monogenic, meaning they form during a single explosive eruption event. Seismic activity in this zone is almost always tied to the phenomena of bradyseism, a slow upward movement of the ground caused by pressure variations in the underlying magmatic system. 2 days later, on February 7th, a magnitude 4.8 earthquake was recorded in the southern Tyrrhenian Sea near the Aeolian Islands, at a depth of 17 kilometers, roughly 10.5 miles. The quake was felt across the islands and along the northern coast of Sicily. During the same days, Mount Etna was also showing faint but spectacular volcanic activity, with the emission of a lava flow at an altitude of approximately 3,000 meters, or about 9,840 feet. This activity was preceded by an explosive eruption on February 6th. These are the facts, but the question we want to answer in this video is there a common cause behind these events? The scientific community is quite divided on the issue, though most experts lean towards the idea of a coincidental overlap in timing. Skeptics argue that the earthquakes in the Aegean and the activity at the Campi Flegrei are like two neighbors living in separate apartment buildings. They share the same neighborhood, the Mediterranean, but they don't share a wall. The Aegean shakes because the African plate is sliding beneath the European plate, creating stress along local fault lines. The Campi Flegrei, on the other hand, are like a volcanic pressure cooker. Magma and gases beneath the caldera move, pushing up the ground and causing frequent micro-earthquakes, and occasionally something far more significant. In short, there doesn't appear to be a direct geological thread connecting two areas separated by 1,000 kilometers or about 621 miles, and tectonic forces can't exactly talk to each other across such a distance. It's like trying to blow out a candle in Naples from Athens. It's impossible. What's more, earthquakes are so common worldwide that it's entirely normal for two events to occur within days of each other without any connection. In the view of mainstream science, there's no geological mechanism that could plausibly explain a cause and effect relationship between these two seismic sequences. But there's always a but. Some less conventional seismologists have started entertaining alternative scenarios, defending their theories by suggesting that when a strong earthquake occurs, like the one in the Aegean, the seismic waves travel across the planet. These aren't just ground-shaking tremors, they're like drum beats reverberating through the Earth's crust. And one of these vibrations gave a slight nudge to the already unstable system beneath the Campi Flegrei, like gently pressing on a can of soda that's already been shaken. It's an intriguing hypothesis. Some studies, like those by Ross Stein, a superstar geologist, suggest that in rare cases, seismic waves can destabilize volcanoes or fault lines that are already on the brink. A second point, the Mediterranean is a puzzle of colliding tectonic plates. Could tectonic stress be spreading in a more diffuse manner, like a blanket being stretched in multiple directions? Maybe the two areas, though far apart, are responding to the same tension being pulled taut. A third thought, history teaches that sometimes distant events synchronize. In 2011, Japan's mega earthquake was followed by 2 weeks later by the eruption of Mount Hiroshima. Coincidence? Perhaps, but who can say for sure? Hey guys, just a moment before we continue. Be sure to join the Insane Curiosity channel. Click on the bell, you'll help us to make products of even higher quality. So what should we think? Why is there such a stark divide in how this phenomena is interpreted, especially when it seems unlikely to lend itself to such opposing views? Well, part of it surely stems from the fact that the entire area, including southern Italy, Greece, with the Aegean and the Turkish coasts, is a true seismic zoo, where all kinds of geological phenomena merge and clash without any clear boundaries. It's like saying the pieces of the mosaic are so interwoven that it's hard to rule out the possibility of a domino effect between distant regions, even if those regions exhibit profoundly different geological characteristics. And this is exactly what we at Insane Curiosity believe. From the dawn of Earth's formation, the Mediterranean basin has been one of the places where tectonic forces have showcased their immense power. The region lies at the intersection where the African plate relentlessly pushes against the Eurasian plate, moving at a rate of about 8 to 10 centimeters per year, roughly 3 to 4 inches. While this shift might seem minimal in the short term, over a century, the accumulation of mechanical energy reaches levels capable of triggering megathrust earthquakes with magnitudes exceeding 7, powerful enough to reshape entire landscapes. Geophysical data collected through ultra-sensitive seismic networks and satellite monitoring reveal that in certain areas, the release of accumulated stress resulting from this continual subduction historically occurs in 2 to 3 significant seismic events every century. Take the Campi Flegrei, for instance. Monitoring stations in this area have recorded an average ground uplift of 2 to 3 centimeters per year, or about 0.8 to 1.2 inches, a clear indication that magma is steadily accumulating beneath the region. While this phenomena isn't something to take lightly, the buildup of such immense pressure, if suddenly released, could generate a devastating earthquake capable of shaking not only Naples and its surrounding areas, but potentially reawakening the Vesuvian magma chamber or activating the Tyrrhenian fault. Meanwhile, the volcanic system of the Cyclades, with Santorini as its most iconic symbol, tells an equally dramatic story. Around 1600 BC, the massive eruption of the island of Thera had world-altering consequences. According to estimates, millions of cubic meters of magma were ejected, forming a colossal caldera and dispersing ash thousands of kilometers away. This eruption wasn't an isolated event, but part of a long cycle of volcanic activity that brought the Minoan civilization to its knees, forever altering the Aegean's landscape. Geologists are convinced that due to the persistent accumulation of tectonic stress and ongoing magmatic activity, the region has never truly rested. Instead, its restless nature remains evident, manifesting in the occasional microseismic activity that feels like the faint breath of a slumbering giant. But the Mediterranean's geological history isn't limited to producing cataclysms on dry land. The Tyrrhenian Sea, lying between Naples and Sicily, is dotted with dozens of underwater volcanoes that are still active. Similarly, beneath the waters of the Aegean, seemingly dormant volcanoes lie hidden, remnants of the same processes that form the Greek islands. How can we dismiss the possibility that energy waves from a tectonic earthquake might disrupt the sleep of these giant undersea volcanoes? And what if, in turn, their magmatic adjustments trigger nearby faults? The Mediterranean, with its intertwined geology, is very much alive. A vast, interconnected system where every component, from mountain peaks to the ocean depths, play a role in a perpetual cycle of destruction and renewal. It's as if, though, the Mediterranean were a massive natural laboratory, where the Earth itself, through a combination of chemical and physical reactions, continually records cycles of collapse and resurgence. What we're looking at, then, isn't a collection of isolated phenomena. Rather, it's an integrated system where every small tremor sets off a reaction that alters the composition and thickness of surface layers. Each disturbance hints at a deeper, interwoven complexity, reminding us that this region is an extraordinary symphony of geological forces, eternally dynamic and inextricably connected. Sand, dust, and fragments of rock are constantly redistributed, creating an ever-changing mosaic. Satellite remote sensing technologies and geodynamic monitoring networks now allow us to read these patterns with unprecedented accuracy. But even so, nature remains enigmatic and unpredictable. Every piece of data, every measurement, whether it's the uplift recorded at the Campi Flegrei or the rapid intensification of microseisms at Santorini, provides clues about what could happen if, pushed to its limits, the accumulated pressure were suddenly released in a catastrophic failure. Geological evidence suggests that Mount Vesuvius, the Campi Flegrei, and even the ominous volcanic system of Santorini are not isolated phenomena. Some studies indicate that the regions beneath the Mediterranean arc share a common language, where tectonic stresses and magmatic activity are interconnected. For instance, certain researchers argue that microseisms recorded in distant areas may actually be part of a larger global stress system stretching across the entire basin. If this hypothesis holds, it would mean that an event occurring in one location, like Santorini, might not be isolated, but instead part of a much broader framework of geological instability, spanning from the Gulf of Naples to the Turkish coasts. In conclusion, the idea that the entire eastern Mediterranean, from Naples to Turkey, might be geologically interconnected is no small hypothesis. The earthquakes and eruptions of recent days, both at the Campi Flegrei and Santorini, could very well be part of a single massive stress system running through the basin. Scientific evidence, from ground deformation data to microseismic measurements and numerical simulation models, suggests that we may be on the brink of a dramatic shift. It's as if a giant long sleep is suddenly stirring, ready to overwhelm the region with devastating but not entirely unpredictable consequences. This potential future demands urgent attention, investment in monitoring infrastructure, and a radical revision of emergency plans. Only with such measures can we hope to coexist with the fury of the forces that have shaped our millennia-old story, turning the Mediterranean into a stage where the drama of destruction could be set at any moment. The concept of a new Pompeii isn't just a far-fetched fantasy. It's a possibility rooted in geological history. During the eruption at Santorini, it's estimated that the energy released exceeded 10 megatons of TNT, and that event was powerful enough to alter not just the landscape, but also the region's climate, spreading ash across half the hemisphere. Today, combining the accumulated tension along tectonic margins, the increasing frequency of microseisms, and the continual stress exerted by the subduction of the African plate, Simulations suggest that in the not-too-distant future, we could witness a new wave of destruction, a mega-earthquake, followed by a series of eruptions that could trigger tsunamis of such magnitude as to submerge vast coastal territories. Picture cities like Naples, Athens, or Istanbul being struck by waves that, in mere minutes, reduce their urban landscapes to ruins, as volcanic ash rains down like a black shroud, cooling and darkening the skies and leaving behind an apocalyptic panorama.